Okay. Let's just get rolling here. If Bobby and Basil show up, we'll get them into it here. So this is me here. We'll be talking selecting fasteners and wood frame construction here today. Um, the first thing I want to ask you too is, did you participate in my async session there, Broden and Marion? Did you guys go check out my blog?
I I did. I checked
Yep.
out your blog maybe like a week and a half ago. Probably wasn't
Okay.
the smart. So I checked out the blog a week and a half ago, and then I did your quiz this morning. I
Oh,
probably should
perfect.
have done the quiz right after the checking out the blog. But yeah, I did check it out, and I did your quiz as well.
Nice.
Sorry,
And
I did
did
not.
you
No.
didn't, hey? Okay. Now,
No.
Broden, did you watch the videos or did you do the reading? Like how did you prefer the media?
I didn't. I don't think I watched the videos. I was going through a couple of people's, and yours was one of them. Because you had, isn't there somebody else doing fasteners too? Isn't there?
Yeah, Kyle had done fasteners for kind of like automotive and heavy duty applications, so bolts and that
Yeah,
kind of thing. Yeah,
yeah,
we'll be looking more at wood frame.
yeah. So
And
I
then
100% did your quiz. I'm second guessing myself if I read your async or Kyle's or both.
okay.
Um, yeah, I'm not sure.
Okay, that's just I'm just curious about how people are, taking in that information. Now, in your guys' opinion, how would you order this? Synchronously first or async first? I found it a bit strange personally that the sync session came before the async session. To me, my opinion, I'm a big flipped classroom guy, so I like to see students try to learn something on their own and then come to school first. So where do you guys stand on that?
What I did in this course, I like agree with the flipped classroom idea as well. I posted my asynchronous session. It's not completely related because my asynchronous session it's about like the different oral hygiene like tools, which toothbrush,
Mhm,
electric or manual, what floss, and so on. Tomorrow, it's more of the application. So even though that if you didn't get a chance to read it, it will be still
mhm.
be relatable because I will touch on it. If you're using this is how you do it. If you use this is how you do it.
Perfect.
But yeah, it's depending on the topic though, in my opinion.
Mhm.
So
Yeah, I think
What
that's
about
good.
you,
That's
Broden?
good though, Marion. Kind of like, at least it's related in a sense. I feel because is there, I believe async first and then sync. That's the standard. Am I correct in saying that? Or do you
I,
guys know?
well, this is the whole question for me is the chicken and the egg. Like the way it was structured is to do module two and then module three. Module two is synchronous, module three is async. And then
Hmm.
I did email Dwayne and he said, do it however you like. So I
Yeah.
was just curious about how you would structure it, you know.
I
he
would, well,
actually answered.
I would,
Sorry, go
yeah.
ahead.
No, it's okay, no problem. I'm also, I think I agree with both of you in the sense that um, I'm assuming that people for when I do my session or whatever would do the async first. And then so when you're talking about it, kind of like what Marion was even just saying, even the fact that they, you know, kind of have read a little bit about toothbrushes or whatever it is, then you can kind of go into greater depth. But then it's also like interesting because I know Dwayne was like big on not necessarily learning or teaching in the synchronous session,
That's
right?
what I'm, yeah,
Yeah,
yeah.
so that's kind of threw me for a little bit of a curveball. So when I structured mine, I kind of put more of the um information in my async, and then
Yeah.
I'm planning my synchronous one to kind of you know, talk about information from the async a little bit, and kind of expand on it and kind of ask questions that will make people think, I guess, not
Mhm.
necessarily, teaching in a
Yeah.
sense. So it's, yeah,
Yeah, yeah. Like I think the idea here is with this, what we're doing here is that we can have a back and forth and we can unpack what we were reading, maybe solve
yeah,
some of the problems that we ran into. But to come into this session with some prerequisite knowledge on the subject, I think is incredibly important. Okay.
100%,
Okay.
100%.
Yeah.
So let's and thank you for that feedback there. I know it's a little bit outside of what the presentation is here. So let's just get into it here. So we're talking fasteners and wood frame construction, and these are the results of considerations or lack of consideration. Okay, so we're going to be looking at things like shear strength, fastener type, installation. How does that play a role in this deck collapse? I think it would be incumbent on me to at least do a little bit of explaining maybe how these things relate. So up at the wall here, this is what's called a ledger. And this is effectively what supports half of the weight of this deck. And this is a commonly overlooked installation. And shear strength, fastener type, and how we apply it is really important to this connection here. Okay. We'll be looking at things like the head type, the shank size, and whether or not pre-drilling is important. You can see in this picture here, we've got a carpenter installing some finish nails, and we've got a split here. And so, how can we avoid things like that? And why would I elect to use a fastener like this? We're going to look at application. Why would I choose to use a screw in a deck application over a screw to frame a wall together? The importance of resisting corrosion for exterior decks, exterior work near the salts, anything like that. Then how appearance plays a role as well. Some fasteners are left exposed, and so we need to consider that. Lastly, we'll do a little bit of just kind of not material science, but a little bit of material science. So what's ductility? How does ductility and brittleness play together? How does that affect durability and the longevity of the fastener here? Over here, you can see a broken screw. Over here, you can see a nail, and the nail has been able to be twisted around and malformed into this shape without breaking, and the screw over here has sheared off. And this is a major issue with screws in wood frame construction, is they lack ductility, okay? So this is a good picture of the difference between a ductile material and a brittle material. There's the Cole's notes of what we're going to be doing here. Okay, so recognize key factors influencing fastener design and selection, differentiating between withdrawal and shear strength. You guys know what shear strength is? So shear would be the ability of this pen to resist me sliding my hands this way, or how scissors cut through something. And then pulling out would be withdrawal there. Corrosion, then assess fasteners for application-specific requirements. Security and durability. So I'm not sure if you've ever considered security, like can a burglar take the screws out of the hinges in my exterior door? And at that point, it doesn't really matter how many deadbolts I have. We need to think about that as well. So here's a group question for you. When a carpenter is selecting fasteners on site, what is the top consideration? Take a moment there. You can have multiple answers.
Definitely not what's in my tool belt. I would like to think that.
Strength?
I feel
Strength?
Does
it feel like maybe there's more than one right answer here? Yeah. Maybe
I would think B and C, strength and corrosion resistance would be, I don't think it should be what's in your tool belt, and what's in your tool belt and speed and convenience kind of go hand in hand, in my opinion.
Mm-hmm. I think, yeah, you're definitely on the right track there. The reality is we need to meet the strength and corrosion resistance requirements, but, we will not be efficient if we're hand nailing a whole house together. Okay, so speed and convenience, and it's not going to be cost effective if I have to special order fasteners from across the world and have them shipped in. So having things that are available local, convenient to get, and then using things like, air nailers and power tools. And then also D, I mean, of course, D is not the right answer, but this is what we do wrong. We have something in our pouch, and instead of climbing down the ladder and going to the C can and grabbing the appropriate fastener, we just put what we have in because we don't appreciate why we need the good stuff. Okay, so there's I would say 3 correct answers here: A, B, and C. Then D is the harsh reality of it on the job site.
Yeah, no kidding.
So do you want a screw or a bolt or a nail? We're going to talk about what's the difference between those things. How much shear strength do I really need? Some fasteners, you don't really need any shear strength at all. Like, for example, trim work. I'm not really needing a lot of shear strength to hold trim around a door or a window. I'm more concerned with its withdrawal strength and how that fastener is going to look long term. Okay. Shear strength is going to be relative to the diameter of the fastener. Okay. So without getting into different types of metals, we'll just say that a thicker fastener will resist shear better than a thinner fastener. Okay. With withdrawal, we'll be talking about is this a good application for a fastener that would resist withdrawal? Okay, and how we resist withdrawal is by having a texture, so a coating on that screw, or the shape of the fastener itself. So a nail that's twisted is an RDox nail. You can put little deformations around the shank of the nail called a ring shank nail, or you can put heavy duty coatings on them that have when they go into the wood, it bites it and resists pulling out. Kind of the worst thing you would want for withdrawal is a smooth, shiny nail. Okay, that's what you're going against. Okay, how will moisture and how will moisture and chemicals affect this? Okay, so fresh water, salt water, and then if you don't know this, there's a product called preserved wood. Okay, it's used in exterior applications, and it uses a chemical that when it incorporates water, so when it gets rained on, it can actually deleteriously affect fasteners quite badly. Okay, so there's concerns about using heavy duty galvanized fasteners or stainless steel fasteners in these applications. Okay.
So is that like
And then
pressure
how will the
treated
head
wood
type?
too?
Sorry,
Sorry.
go ahead, Broden.
Is that like pressure treated wood too, or is that something different?
Yes, yeah, preserved wood, pressure treated wood. That's the it's basically impregnated with arsenic and some copper. And the issue here is we get what's called a galvanic reaction. You get steel in contact with copper in contact with water and dissimilar metals. We won't go too far on that, but it is a concern and a consideration when we're selecting fasteners. Okay.
Cool.
And then, as I mentioned before, we have to consider the architectural impact. Okay, and meaning how is this going to look? We can't just approach everything with big head common nails because our customers are not going to be happy with the overall look of that. Okay, so I kind of want to let that be my teaching, if you will, for this lesson here, in an effort to give you a little bit more context into what we're going to be doing. Okay, just a little bit of feedback here, Marion. You doing okay?
I'm enjoying some of the words because we use the same words when it comes to dental materials. So corrosion, shear, strands, all of these, it needs to be in
Of
that
course.
filling material. So
Cool.
And
I'm following.
fasteners. I mean, I'm looking at fasteners and wood frame construction, but you're putting tungsten or not tungsten, maybe titanium screws and stainless
Exactly.
steel,
Yeah.
and of
Yeah.
course, of course. And so the same issues are at play, just a little bit different. Okay, so we're not going to do any breakout rooms because there's only three of us. And what I'm going to do though is I'm just going to show you this scenario, give you a little bit of guiding topics here. Then I'll let you and Broden have a discussion about it, and I'll just float here. If you have any questions, you need anything clarified, feel free to ask me. Okay.
Cool.
So what we've got here is we're building a deck by the ocean. Okay, so we'll be exposed to salt water, moisture. I've got a picture here to show you, what we're doing here. Here's the deck. This is the ledger board that's going to be bolted to the wall. These are the joists that get fastened to the ledger board. This is what we call the framing. This is the structure of the deck. Then we've got the decking itself. And this, for most exterior decks, it is part of the structure, but it is also the architectural plane of the deck. This needs to look good and needs to last long and not create tripping hazards and all these kind of things. Okay. So I want you to think about what would you use for fasteners for the ledger, the framing, and the decking? How would the marine environment influence that choice? And what component would benefit the most from having a fastener with very good withdrawal resistance? Okay, and I'll leave this slide up. So discuss.
Alrighty. So we're building a cedar deck attached to a home located near the ocean. That's pretty key. Deck framing and ledger are pressure treated lumber. Okay. So what types of fasteners would be used for the ledger, the framing, and the decking? So I think, definitely because it's near the ocean, salt water, corrosion, and stuff like that, is going to come into play. And then also we were just talking about the pressure treated lumber. Um, so I guess that's going to come into play too, the different types of fasteners. Were you didn't do the his little quiz before Marion, did you? Or no?
I don't think she
Sorry.
did.
No, I
The
I did not. No.
Okay, no problem. I know one of the questions in there was talking about um the fastening to the ledger. And I chose the wrong answer. So no, I kind of I think I know the answer to that. Um, so I think my opinion, I think for I guess we can go question by question.
Mhm.
For the ledger, we would probably want to use some type of a nail. Um, I just don't know because it's pressure treated, what type of a nail exactly you'd want to use.
Okay. Well, keep moving on because we're going to wrap this slide up, and then you'll be much more well informed at the end of this slide for the second guiding question. So keep going there. You've selected a nail for the ledger board. What do
Yeah,
you think about nailing the joists to the ledger?
maybe a screw, I'm thinking.
Okay.
Um, Again, I don't really know exactly what the proper answer would be based
That's totally
on
fine.
pressure treated.
I'm giving you guys basically a second year or first year apprentice kind of like session here. So
Yeah,
I'm not expecting anybody to actually get the correct answer here, just more to have the discussion.
yeah, for sure. I would assume, yeah, either like I don't know if I assume you'd want stainless or something like that, but I'm not
Right?
100%.
Yeah, you're on the right track there for sure.
Which
Now, if we
component?
think about shear strength and withdrawal, we got a ledger board, we got a joist, we got decking here. I've asked you about withdrawal strength. Which one of those do you think would benefit the most by having a fastener that doesn't work its way out?
Not the smooth one.
Yeah,
Uh,
exactly. So like
I don't know what it's
Okay.
called.
Yeah, well, I'm not asking for the fastener type. I want to know of these three components, which one of these would benefit best by using, say, a screw. A screw resists withdrawal better than a nail.
Uh,
I guess
Let
because
me ask
like
you another question. Have you guys ever had been over to a friend's house, or maybe you have a deck like this at home where you're walking across the deck and your
yeah,
socks
yeah.
are catching nail heads?
Oh yeah, I was just thinking that. Yeah,
Yeah.
oh,
so that I guess
Yes. So
the
so
top boards.
this is, I mean, because we all live in homes and
Yeah,
intrinsically we all have a little bit of experience with framing and bad
yeah,
fastener selection. So the idea here is that it's the decking here that would benefit the most. So let's take a look at the next slide here. I've got kind of answers to your questions here. Okay.
sweet.
So when we're looking at the ledger board here, uh, this is going to be a fastener that requires high shear strength because it is carrying effectively half the load of this deck. Okay. Now here they've got a little prop under it. Let's not worry about that. So I would be selecting a likely what's called a lag bolt. Okay. And this is effectively just a massive wood screw, about a half inch thick in diameter. Then the length, of course, would be relative to the wall I'm going into. Okay. That's a very common fastener to use for ledger boards. For the joists, I would be nailing them together with nails because nails are the best for framing. They have great ductility, and framing is typically always arranged so that you're never in withdrawal. Everything is arranged in shear. Okay. Lastly, the deck here, I would be selecting a stainless steel screw, right? So we want the screw to resist the withdrawal strength. We're not as concerned with shear strength in an exterior deck application. A little bit more of a concern inside the house with the subfloor because that does provide lateral bracing for wind and seismic. But this would be more for the architectural appearance as well as resisting working itself loose over time. Okay. And because it is a marine environment close to salt water, you would ideally budget permitting go with the highest quality fastener you could, which is a stainless steel. The next best would be what's called a double hot dipped galvanized. Okay. Now you got a little bit more information, right? I was able to kind of connect a few more dots. So take a look at scenario number two. Okay. I won't prompt you on this one. I'll let you two read what I'm asking you here.
What do you think,
So what
Marion?
do you
Any
think?
guesses?
I would say nails. What type of
Nails for the
fastener?
subfloor? Okay.
I'm not sure. I feel like it because it's uh, because it's in the roof, correct?
Yeah,
Or
it could be. Yeah, no, the shear strength is important, right?
yeah.
Absolutely. When we talk about framing in the house, the shear strength is totally important. Okay, so Marion, you're saying nails. What do you guys think about the question two there? Is withdrawal resistance a concern with subfloor as well? Meaning the same issue we had with the deck boards. Could that happen inside the house?
I feel like
I would say still
feel
yes,
like it
because
could, but I don't know. Is maybe the
Yeah,
the temperature variation is less or something?
absolutely. Listen, like anytime we walk on
Yeah.
something, the reason those screws have worked their way out or the nails have worked their way out on the deck boards is often because of environmental changes. So the wood will
Yeah.
expand and contract with moisture and seasonal temperature. But inside the house, it's people walking on it too that will cause deflection. And so, absolutely, anytime we're doing any type of floor application, withdrawal resistance is a concern. But again, the shear strength is more of a concern here as well. Okay. Now, being as this is inside, if you've ever seen a house being framed, you got to frame it outside and then eventually you put a roof on the thing. So we are going to have exposure to moisture, but do I need the same kind of requirements as the last scenario?
I don't
mm,
I don't think so, but you kind of just the fact that it's going to be, I never really thought the 2 weeks, exposed. I don't know
Yeah.
how much that really plays into it. That even gets taken into consideration,
especially
or
it's rainy conditions like here. So
yeah,
Yeah.
like
Do you think that maybe the people who manufacture fasteners for framing homes, they might not go to the same trouble of saying use a stainless steel or use a double hot dipped galvanized, but maybe they've done a light duty electroplating on
okay,
that fastener. And that gives it some corrosion resistance for a month, a couple weeks, but
okay,
isn't
that makes
anything for
sense.
permanent.
So is that pretty standard? Like, do most come
Yeah.
like that?
Yeah, absolutely. Most gun nails will come with some type of either really light duty electroplating on it or a
Okay,
coating of oil or something like that. But the reality is, even if you use a common nail, a bright finish nail that has no coating, we are not concerned about any type other than a little bit of surface rust. If you see a bit of surface rust, that's not going to negatively impact the structure overall. But if you were to leave that exposed for a year or several months, that might be a different story.
okay,
So when we look at the answers here, you're both right. I've built many houses and I have installed a lot of subfloor with both screws and nails. And the reality is, if I'm going to use a nail, I'm going to use what's called a ring shank nail. And this is a picture of a ring shank nail. And you can see here that it's a nail that gets driven in, but it has these rings on it that will resist the withdrawal. If I'm
okay,
going to screw it off, have either of you ever driven a screw before?
yeah,
Yeah, it's a bit time consuming, and we're talking about thousands of these things. So they make special fastening guns that you can stand up with, and they've got all the screws on a strip. So you're going to use one of those. But the point is, either one is great. I would say preferably a screw. It would beat a nail in performance for subfloor, but both are good. I'm not going to get into it too much with this lesson, but they also use adhesives under here. Okay. We always use something called a subfloor adhesive. We're trying to avoid squeaks. If you ever had a squeaky house floor, this is a major concern for callbacks for contractors. Okay. Um, if you didn't know the difference between, I've mentioned it several times, double hot dipped galvanized and electroplating. Hot dipped galvanizing is when they have a molten bath of liquid zinc and they dip the fastener in and they dip it again, and it's going to give an appreciable thickness to that coating. There's a bucket here that's been hot dipped galvanized. Then this is electroplating, and electroplating is effectively where they'll put this in a solution with dissolved metal and they'll apply a micron thin layer. Okay, so not nearly the same level of corrosion resistance. All right, here's the last scenario. Take a quick gander at this one here.
pre-finished exterior
And
trims.
let me
Okay,
just clarify one thing, and maybe I should have clarified this earlier. When I'm asking the type of fastener, we can just simply break that down into a bolt, a screw, or a nail. Okay? And then we can look at a little bit more specifically.
okay. If
So
we're
what do we
just
think?
doing
I would say
trim, I would think some
Yeah.
type of I don't know, like a ring nail, like you're saying, something that can be driven in quick, maybe that doesn't have a that has a what is it, high withdrawal resistance? Is that what it is? You
with
want a
the
high withdrawal?
gun,
Yeah. So these are the trims here, okay? This is the trim stuff here. And do you see any nail heads in this? I don't. I mean, we're far away, but there's
Yeah.
no big nail heads that we can see, hey?
Mm-hmm.
Yeah.
So this is where, when we get into this line of work, we're going to change gears a bit, and we're going to think that the function here is form first, okay? So, or the idea here is that we need this to look good, okay? So I'm going to actually get into what's called a casing nail, okay? Um, why would the withdrawal resistance matter for this? And is there other ways that I could improve that?
I would assume because it's exposed to the elements, I would think because it's exterior,
Yeah.
like the expanding and contracting. That would be my first guess for
Okay,
withdrawal.
It's
so
interior.
instead of using a screw, I could use a nail, but I want to improve the withdrawal resistance of that nail. Yeah.
Yeah.
And we've also established that it is exterior, and so some corrosion resistance would be good. So this is where I might lean towards a double hot dipped galvanized casing nail. I get the small head of the casing nail. I get the added withdrawal strength, and I can install those with guns or I can install them by hand. Okay.
Yeah, makes sense.
So that's a casing nail right there. And you can see that the head of the nail, this would be useless for framing applications. Uh, the head of the nail does play a role in shear strength as well. I don't want to go too far into that, but these are used for finish work. And the reality is there is no structural requirement to this finish work. If I was concerned about this working its way out over time, I can just use more nails. I could back it up with some adhesive, but this wouldn't be as prone to working its way out like a deck would, because these aren't really seeing the service loads that a deck would there. Okay. So we got a few minutes left here. I've got some questions here. I'm going to give you a chance here. You know, we got A, B, C, D. We got a fastener to fasten a 2x10 pressure treated ledger to a wood frame exterior wall. So thinking about scenario one there. You'll have to just say your selected answer there. I don't have this set up anything other than a PowerPoint.
I'm gonna say the 1/2 inch galvanized lag bolt.
Yeah, that's good. Yeah. So what the issues are here with the other two answers is well, this is the lag bolt. This would be another acceptable bolt. This is called a carriage bolt. This is also a security bolt. You can see here that when this gets installed, this head here, you can't put a wrench on that. So this could be used for exterior doors or anything that you don't want someone to take off. I've used these a lot for ledgers if I can get inside the house and I can put a washer and nut on the other side.
Mhm.
This is designed to sink its way into the wood frame wall without having to go inside. Okay, this would be a 6-inch common nail. What makes this not particularly good for this application is it's a common nail, and bright finish is what kicks it out. A bright finish has no corrosion resistance. A 4-inch coated screw is too brittle. Unless we talk about framing screws exclusively, these cannot be used for any type of structure. They break instead of bending. Okay, a 3-inch box nail. What this one makes it incorrect is a box nail is a very, very thin diameter nail. It's about the same length as what you'd see for a big framing spike, but it's used for making boxes. So instead of split the sides of the box. Okay, so if you'd paid attention or done the async session there, that's where those come from. Do a few more here. Which nail does not perform well in withdrawal?
A, I think I
D, I
heard.
think.
I mentioned RDocs. What do you think, Broden?
I think D, the bright common.
Yeah,
Hmm.
yeah. So I don't have well, actually, I do have a picture. Here we go. So the correct answer is D. These are what we use, these are what we use for framing houses. They have no corrosion resistance, excellent shear strength, not very good in withdrawal because they're smooth. Okay, and I want to be clear that this is not a ring shank. This is an artifact of when the nail was produced at the factory. There's almost no texture to that. It's more visually than something you can feel. Now, this is an RDocs nail. These have excellent withdrawal resistance. In fact, they're so good that most of the time it pulls the nail head off. So I try to avoid using these because if you ever misplace a nail, good luck getting it out again.
Oh, okay.
If we look at B, that's a ring shank nail. Again, those have excellent withdrawal resistance for sheathing. And then this is what's called a hot dip galvanized, and you can see the coating on there makes it very good at sticking in. If you wanted to order these hierarchically, this would be the best, second best, third best, worst option for withdrawal. What do you think of this one?
Uh, B.
That's right. Yeah. So we got to be careful here. They do now make structural grade wood screws. They cost a lot more. And when you go to the hardware store and you grab a handful of screws and throw them in a bag, you have to appreciate that those are brittle screws and they have limited applications for things structural. Okay. So we're going to use them for fencing, for decks, for trims, things like that, but not for laminating beams or installing framing. Okay. This is a graph of stress and strain, okay, and how a ductile material will start to yield and it will start to deform before it fails, okay? So I will reach effectively its yield strength, but I will have time and indication that this fastener is failing. It'll start to bend or yield. Whereas when I get into a brittle material, I don't have nearly the same amount of feedback. I get basically a catastrophic failure. This can be the last question here. How can the installation of fasteners be made more efficient?
I'm gonna say B by using power tools.
Yeah, what do you think, Marion?
I agree. This is a gun thing, right?
Yeah,
Yeah.
totally, right? So at the end of the day, that's going to take a backseat to the proper fastener. We got to select the right fastener for the job. But then the next thing I'd be asking myself is, well, how can I make this a little bit more cost effective? If I have to build one of these, maybe I'm going to drive the nails by hand. If I'm building 100 houses or I'm going to take on a contracting business, then I'm going to go out and buy power tools to drive these fasteners. Okay. That's what this looks like here. So these are what are called collated fasteners here. So they're all ganged together. This is an assortment of air tools. There's been a thing in the trades, in the last decade where it's been the cordless revolution. So in the past, cordless tools weren't very good. It was the battery technology that kept them down, but that's been overcome. And so now it's very common for people to have cordless everything, and they make nailers and screw guns and all that good stuff. Okay. So, summarize and reflection. What are the key takeaways, right? We got to understand how strength, durability, and safety play a role. We have to match corrosion resistance to the environment. We know that effectively the worst environment would be near the ocean or saltwater spray, okay? We also know that the chemicals that are used in pressure treated wood will play a role in corroding fasteners as well. So let's consider that. We also appreciate that houses, when they're getting built, will be exposed to moisture, but that's for a limited amount of time. So simple electroplating or no plating at all would be sufficient for those. Okay. Do you guys feel like you could differentiate between shear and withdrawal strength a little bit better now when it comes to fasteners and the considerations?
Yeah, I would
Sorry
think
about
so.
that. Application, right? So, this would be getting into the weeds with my class. We would spend another hour talking about this for different applications, but we know that a deck board and a ledger board have vastly different requirements for the amount of fasteners that need to attach to them and the properties of those fasteners. Okay. We're going to balance out appearance and performance as well, right? So I know that a big wood screw would do an excellent job of attaching those wood trims to the fascia board of my house, but it's going to look like crap, right? And so I tell my client, yeah, but it's going to be there forever, and they go, well, it's going to look like crap forever then, right? So we got to balance out the cosmetic with the performance there. Okay. Anything you guys want to contribute or any feedback on this or any questions for me?
Would you say like sheer strength, like mainly is like for things that you're installing like vertically? Like, would you ever consider sheer strength when you're installing like deck boards or anything that you're, fastening down that, or is it mainly that
Yeah.
you're just selling something, vertically that has that gravitational pull constantly?
Without getting too in the weeds, that's such a great question because this is where the nuanced application would come in. So, for example, an exterior deck where you've got like rain can pass through it, that deck is not adding any lateral bracing to your house in a high wind event or a seismic event. Okay. So there would be no requirement for the deck boards. The requirement would be hold the deck boards down and don't let them come loose.
Yeah.
That's it. When we get inside of a house, the floor sheathing, when we fasten the sheathing to all of our structure, this becomes what's called a diaphragm. And when the earth shakes, when the wind blows, this diaphragm is what is keeping your floor system from turning itself into a parallelogram. So when we look at sheathing subfloor, shear strength. Okay, well, unfortunately, I ran out of time with my Zoom meeting and it dropped my last 30 seconds of my presentation. So I was with Broden and Marion, and we were just finishing up our key takeaways, talking about balancing appearance and performance. The last thing I wanted to talk about here were just my references for this presentation and some of the information that came off of my async. Okay, so I got my information from the training modules for the apprentices here at Camosun College from Queen's Printer, King's Printer now, and then Google image search for most of the fastener stuff like that. I made the quiz myself and input a lot of the content myself as well. Thanks for the participation. Bye now.